everyone, and welcome to Relativity Fest 2020. This is the Using Behavioral Analysis and AI to Detect Misconduct in Your Communications session. If you have any questions during the session, please enter them in the chat. I'm Jordan Domash, the GM of Relativity Trace. I'm joined with Peter Haller, Senior Product Manager, and Eileen Tien, Trace Specialist, and we're really excited to walk you through how to leverage AI in surveillance. The agenda for today, there's a few topics. We've got the AI and relativity and our history with these types of technologies, why it's really important to use it in surveillance to get the most value out of your surveillance system, and our surveillance strategy within Relativity Trace. But before getting to all of that, I wanted to just start with an introduction. What is artificial intelligence? I know it's used in a lot of different ways. People think about artificial intelligence and sometimes come to different conclusions to what is AI. And we use a definition that's listed here. Artificial intelligence is a computer system that supplements human capabilities by identifying patterns in data, learning from experiences, and making statistically based decisions. There's a few elements that are really important in this definition. The first is that we supplement human capabilities. We don't plan on replacing that. There's always going to be a person that is going to make the ultimate decision of whether this communication, this incident, this misconduct is actually something bad, something that you need to investigate. We view our job as helping flag the riskiest items so you can get to that content quicker. You're spending less time reviewing irrelevant content, but we're not completely replacing the role of a reviewer. And we do that by identifying patterns in data and learning from experience. Every time that you look at an email or a chat or an audio file, and say, this was relevant to what I am looking for, or this is not relevant to what we're looking for, we learn from that. And we identify patterns in those decisions so we can make statistically based decisions. We can apply a risk score to every future incoming communication to see whether it's relevant or not to the specific activities that we're looking for. So we'd like to start with a definition, just explain what we mean by AI. And Relativity has been investing in AI technologies for a really long time. We first released Relativity Analytics, which is the suite of technologies that we use, in 2008 with things like concept searching. In 2013, we released Structured Analytics, which is really widely used today. Structured Analytics is things like language identification and email threading, where we can organize a discrete set of unstructured emails. In 2013, we first hit 1 billion documents analyzed. That was a huge milestone for the company. And it took a long time to really gain acceptance of this type of technology. In 2014, it was the first time that relativity analytics was first found acceptable and defensible by courts. And I highlight that because defensibility is critical here. You can have the best AI technology that filters out every piece of false positive, every false positive that was sent to the system. But if you can't prove that it's defensible, you can't prove that it works, that you're actually catching all of the bad activity, then it's not really worthwhile. So we made a big investment in reporting and defensibility. And for those of you that have been on the relativity journey for a long time, you'll know that many of our analytics technology was actually built a technology partnership. And in 2016, we actually acquired that organization, Content Analyst, because we saw AI was so critical to the future of relativity and Relativity Trace that we needed to own the underlying algorithms so we can double down our investment in them. In 2019, we released Communication Analytics, which allows us to broaden AI to focus on people and how they're communicating with each other. And if you go to 2020, we hit 6 petabytes analyzed. So a ton of data has been through all of our AI algorithms. When we look at the set of features that we built out, there's a ton, right? It's not just one analytics feature. There's over 15 different ways that you can leverage different algorithms to identify specific content that's relevant to you, specific workflows that are relevant to you at the time. So just want to highlight the variety of tools that you now have at your fingertips in Relativity Trace. And why are we making this investment? Well, it comes down to 3 key challenges. The first is we are seeing a massive growth in the volume of communications that everyone is dealing with. You know, if you go back 5 or 10 years, there's not as many communication records as there are today. There's new communication channels. Right now, we're dealing with audio. We're dealing with video conferencing systems like Zoom. We're dealing with Slack and Teams. So it's not just sending the occasional email back and forth. There's hundreds and hundreds of messages that everyone is sending every day across dozens of channels. And misconduct is evolving. The risks of today are very different from the risks of a few years ago, and you need a system that can evolve and keep up. Just to give an insight into the amount of the volume of communications that we see in Relativity, this is the volume of records that are housed in every Relativity instance around the world. At the end of last year, we hit 135 billion records, 135 billion communications. And you can see the fast growth that we've seen over the last 10 years. Let's put 135 billion records into context, right? It's a lot. If you had one person who was reviewing 100 communications per hour, and they spent a full year doing that, you would need 700,000 people to read every record that is stored in Relativity today. That's just impractical. You're not going to invest in that amount of people to get through all those communications. And so you need technology to get ahead, to supplement the individuals that are conducting a review, to identify what's relevant, and to focus on the riskiest content so they're not reviewing every single communication.
Wow, Jordan, that's an insane amount of data, a lot of manpower, and I can imagine that really resonates with those listening, the compliance teams listening today. Just the sheer volume that overwhelms teams. It makes it extremely difficult and quite the undertaking to truly identify misconduct within all that noise. And we talk with a lot of compliance officers and a lot of compliance teams at financial institutions and other highly regulated industries about their current surveillance practice. And we ask them, what are you doing today? And most of them tell us about some pretty antiquated tools that are based around keyword searching. And don't get me wrong, keyword searching is extremely important. It's easy to implement, it's easy to maintain, it's proven within the industry, and it's easy to explain to regulators, which is extremely important when it comes to proof of surveillance audits. But it's not the most effective way to identify misconduct. It generates an extremely high number of false positive alerts. And this is what we've witnessed many of our customers experiencing with their past products. And the high number of alerts, high number of false positives creates a bloat in their teams. Their teams need to grow. They need more people to review documents. It increases their overall budgets. And it's a real challenge for them to keep and stay ahead of misconduct. I always ask them, okay, you're using keyword searching today. What does the future look like? Where do you expect to be in 5 to 10 years? And they all give me some form of the same answer. Some form of artificial intelligence is the answer. NLP is the answer. Machine learning is the answer. Behavioral analytics, neural nets. One of these is going to solve all my problems. It's going to be my easy button out there. Unfortunately, we've learned from a lot of experience that there's not just one easy button. There's not one simple piece of AI technology that's going to solve all of your problems. Rather, it's a suite of AI capabilities, each designed for a very specific task that when combined together can help you understand the holistic picture and identify true misconduct. And Relativity Trace, we know this, and we use a suite of AI capabilities to more accurately identify risk. When we think about what are these different AI capabilities, what categories do they fall into? They fall into 3 different groups. First, we have removing irrelevant content. And removing irrelevant content is the most important piece at the beginning. You'll often hear the phrase of garbage in, garbage out when it comes to performing deep analysis. And removing all the noise, it can sometimes be actually easier, more simple. There's a lot of it, and we need to get rid of it in order to move on to the next step, which is pinpointing risk and misconduct. And this is about building different ways of identifying specific types of risks based off the different risk profiles. It's very important and complex, and it becomes easier to do as you've seen more of it and you've witnessed more of it in the market. And finally, it's about increasing reviewer understanding, making sure that once you have generated an alert, you provide enough information so a reviewer can understand the context, the intent, the pressure, or the opportunity behind a specific action. So we're going to walk you through these different categories and capabilities underneath each each category, so that you can identify how to find misconduct and identify risk most effectively. And so we're going to take all these dots here. Let's jump in. Let's take all these dots as an individual communication. And we're going to start by removing irrelevant content. And this has the ability to slash your communication volumes, almost cut it in half. There's a ton of noise in your data. So to talk about the individual tools that are around removing irrelevant content, I'm going to pass it over to Eileen. Take it away, Eileen.
All right, thanks, Peter. So the first method that we want to look at of removing irrelevant content is within Relativity Trace, that you have the ability to automatically identify disclaimers and confidentiality footers using our analytics engine. And again, this is an automatic process. But however, once the analytics engine has successfully identified which pieces of text are disclaimers and confidentiality footers, the users, you have the ability then to choose what is removed. And the sections of text of disclaimers and confidentiality footers are only removed from the searchable text or the extracted text, and not from your original document. And the end result here is that keywords that would have otherwise hit on disclaimers will no longer hit because the disclaimers have been removed, and therefore, improving your alert results by decreasing the amount of false positives. And then next item that we want to explore is duplicate document removal. Now, as communications are coming into Relativity Trace, we do have a kind of a traditional hashing algorithm that is automatically applied to incoming communications, which will deduplicate exact matches and prevent those exact duplicates from being ingested. Now, post-ingestion, once users are reviewing the reviewing the alerts, they may find that there are similar communications, but that are not exact duplicates of one another, but are so similar that it's causing bloat in the review process. We have an AI tool within our analytics suite called textual near duplicate analysis, and you can use this tool to identify communications that are maybe 90% similar to one another or 96% similar. You set the threshold, and then we can automatically remove or suppress these textually similar communications from review. And again, this is another method of removing irrelevant content and increasing reviewer efficiency. And another means by which we can improve reviewer efficiency is using the AI tool for email threading. So for example, let's say Peter, Jordan and I are exchanging emails with one another, and we're all using keywords in the lexicon. So, on the left diagram you see here, you've got 6 separate pieces of emails from each of us. And without email threading, each email gets treated as a separate alert. But if you apply the AI tool for email threading, the analytics engine applies an algorithm that then allows separate pieces of email that constitute a single conversation. It will thread those emails together, and the result is what you see on the diagram on the right-hand side, where email threading has grouped our 6 emails into one single thread. And it has also identified on the very bottom, you see the very bottom email is highlighted there. And that is what we refer to as the inclusive email, which is in essence the email that contains the unique content. Perhaps this represents the last response that Peter, for example, has sent in the thread to me and Jordan. And what email threading then allows you to do is to, instead of the reviewers having to remove these 6 separate emails, he or she then only has to review the last email in the chain that got alerted on, and not all 6 alerts. And lastly, within email threading, there is also an email duplicate analysis that is automatically run, which will identify emails that are duplicates of one another that may not have been identified as duplicates via the more stringent duplicate hashing algorithm. All right, and next up is ways to remove spam. So of course, when reviewers are reviewing communications that that individuals are sending, employees are sending to one another, there's going to be a lot of junk emails within the communications that got alerted on. For example, you may have a lot of reports or newsletters or emails from email addresses such as support@amazon.com, and you want to suppress these from the reviewers. And the way you can do that within Relativity Trace by inputting email addresses and domains into our exempt list functionality. And the Trace administrator has the full flexibility to add as many email addresses or domains to the exempt list that the Trace administrator would want to suppress from the reviewers. And the end result here, again, like the previous AI tools that we have looked at, is that that alerts that reviewers would have needed to review, they would no longer have to, because in this case, it has been identified as spam and suppressed from review. And next up, I will hand it back to Peter.
Thanks so much, Eileen, for talking about those specific features around removing irrelevant content. Again, that's using AI to remove system-generated content, things like disclaimers and footers, using AI to remove near duplicate, not just exact duplicate content, to reduce alert volumes. It's around using our email threading algorithm to generate just one alert for an email chain rather than multiple, and to get rid of spam content that exists within your corpus of data. Again, removing irrelevant content is an essential start and must be done before we move on to the next stage, which is pinpointing the most risky behaviors within your organization. So we have our list, we have our number of communications here, all of those in orange. It's been cut almost in half. And now it's about identifying those individual alerts, which are now represented here in blue. And to do that, we have a couple different AI capabilities that will help you pinpoint the most risky communications. And that starts with tools that help add structure to the unstructured data within a communication. Tools that help you understand what you should actually be looking for. And ways to identify risk based on how you've classified risk in the past. So to talk a little bit more about the specific tools, I'm going to hand it back to Eileen. Take it away.
All right, thank you, Peter. All right, so one of the ways that we can zero in on the true alerts that we want reviewers to look at is via metadata searching and filtering. And we have 3 separate types of metadata that I'd like to discuss. And I'll focus on the first and the third columns first, and then zero back in on the column in the middle. So first up is extracted metadata. And this I believe most folks are, familiar with this type of metadata. It's the metadata that is pulled directly from a document. And so, for example, Trace is able to extract information such as participants in a in a communication, and place them into the sent to, from CC fields. We can also extract the file type, for example, the time of day, and the size of each file. And what this will help you with is, in addition to keyword searching, you can zoom in on communications from particular individuals that you want to investigate. You can take a look at specific file types. And as for time of day or day of week, you might want to zoom in on communications that were sent over the weekend to see what activities employees were up to on the weekend. The second type of metadata is external metadata, and this will be provided by the client to you. And for example, we can use Active Directory to sync up which employees should be monitored for which types of data. And then clients may also provide you with an external list of email domains and email addresses that they do not want alerts to be generated from. And finally, the most typical external piece of metadata or data is a list of keyword terms that the client wants to generate alerts from. Now, lastly, let's zoom in on the derived metadata. What do we mean by derived metadata? And this is metadata that is garnered from the ingested communications based on analysis of each document, not human analysis, but AI analysis provided through the Trace analytics tools. And as a result of the analytics engine completing this job of analyzing each communication, we can determine which communications are inbound versus outbound. We can determine which communications contain what types of languages. For example, if a communication is primarily French and also maybe has some English words in it, our tool can identify that communication as primarily French and secondarily with some English words in there. And with that, you can zero in on communications where someone may have switched to speaking or typing in a different language to zoom in on potentially bad behavior there. Also, we can extract concepts from communications, and what this allows you to do is to group communications into their various conceptual categories. So, for example, you may be able to automatically group communications together that fall under the umbrella of market abuse. Being able to extract concepts out of communications also allows you to zero in on alerts that are conceptually similar to a true alert that you may have found via keyword searching. And lastly, there is the Relativity Applications Hub, where there are a number of other AI tools out there that you can leverage to produce this type of derived metadata from the communications that you are monitoring. All right, and another way to zero in on true alerts is keyword expansion. And keyword expansion, this is another tool in our analytics suite. And what this does is it expands your current lexicons. So in the diagram or the screenshot that you see on the right here, for example, the word crude is part of our lexicon. Is part of our lexicon word list, and you might not know or be able to think off of the top of your head what other keywords you might potentially want to zero in on that may be related to crude. So what this tool allows you to do is you input the keyword that you would like to find more similar terms on, and you'll see that our results are pretty spot on. The terms gasoline, oil, petroleum, and OPEC, we can tell right off the bat have something to do or are similar to the word crude. And some of the other keywords that are returned might not on the face of things be related to crude, but they could potentially represent code words, for example, that folks are using to talk about items related to gasoline or oil. So you would want to take a look at these other kind of unknown terms. And so the power of keyword expansion is that you can use this to potentially find code words that employees are using to mask bad behavior. And then finally, we have machine learning. And with machine learning, you can develop what we call pre-built models to kind of kickstart your review. And Peter, in the next slide, in a minute here, will talk more about pre-built models. But what machine learning does is that rather than jump into a straight up linear review of all your true or of what you think are your true alerts that have been, alerted on keywords, what you can do is start off a machine learning project, and as the reviewers are coding communications as true alerts or false alerts or spam or not spam, the machine learning model is continuously learning based on reviewer decisions, and it will classify communications that reviewers have not yet reviewed. It will attempt to classify those as relevant or not relevant based on the work that the reviewers have done up to that point. And this diagram that you see here is a visualization that helps you to determine the accuracy of your machine learning model up to that point in time, and also to see the progress that your reviewers and the machine are making. All right, so with that, I will hand it back to Peter to discuss pre-built models and lexicons in Trace.
Thanks, Eileen. Yeah, so when it comes to pinpointing risk and misconduct, just to recap what Eileen went through, we have identifying different types of metadata that can be helpful to find specific communications. We have expanding your lexicon. There's still a place for lexicon searching within your alerting process, and also leveraging machine learning to take full advantage of past review decisions to rank future communications for risk. And all of these different tools to pinpoint risk and misconduct give you full control of how you identify very specific and unique risk within your organization. But truthfully, a lot of the risk is similar across different organizations. And for that reason, we decided to build out-of-the-box policies that you can take full advantage of as soon as you begin and implement Trace to identify different types of misconduct. And they use the metadata, the lexicons, and the machine learning models to accurately identify risk. And this takes our breadth of knowledge and our understanding across many clients' experiences to pinpoint risk now within your specific organization. And it spans across these pre-built out-of-the-box policies span multiple different types of risks. So things like corruption, collusion, customer complaints, market manipulation, insider information, and many more. And you can see the list of some of them here today. So again, this is a great way to write from the start when using Trace to start identifying risk. And these can continue to be manipulated, these out-of-the-box policies, based off of your review decisions. Our machine learning models will continue to learn, or slight alterations you want to make that are specific to your organization. So it's a great starting point for pinpointing risk and misconduct. So now at this point, alerts have been generated in the system. We went from many orange communications down to a couple small alerts. And so now it's about reviewing those individual alerts, right? But when it comes to the original alerts, these original alerts, we have to understand that, malfeasance isn't just about one message, one individual alert. The context around that individual alert, it matters. It helps you tell the story, understand the full picture, and make a better decision about whether this communication needs to be escalated or a specific investigation or action needs to be taken. So we need to do a better job looking at our alerts and finding other communications that tell that complete story. And that sometimes meanders as we gain a better understanding. So I'm going to pass it over to Jordan to talk a little bit about the tools that allow for you to understand not just the individual alert, but the entire context and other communications around that alert.
Thanks, Peter. And I totally agree. Sometimes we think of an alert and how it's reviewed as the end of the story, but it's not. If something is interesting, you need to know the full context of the misconduct that's underlying that behavior. And that often spans more than just one communication, right? It can involve multiple communications, multiple data sources. And so you can actually use AI really effectively to expand that alert into the set of communications that could be relevant to tell the full story. The first thing I'm going to talk about, actually Eileen had talked about earlier around email threading. Here's a different visualization of how you can use email threading to understand the context of an individual alert. Let's say this email all the way over to the right in blue is the email that generated the alert. But you want to know what was the full conversation before and around it. And so each one of these other emails, the other forwards, the other replies, the other attachments that were sent on other emails, you can interact with and jump from one part of the email thread to another. And so email is often it's an unstructured communication format. We can help use technology, artificial intelligence, to apply structure and give you a framework to understand the full context of that email in the broader thread. We can also do that across all data sources. It's not just email. What we're looking at here is our viewer. On the left-hand side, when you get an email, a chat, an audio file, we actually represent that file in a near-native format so you can read through that communication. Let's say you get a long Bloomberg chat, or in this case, a long email. And one paragraph in that email is relevant to you. What you can do is you can highlight that paragraph, click concept search, and what it will do is it will find all other records, all other communications that tell similar concepts. Right, so they might not use the exact same keywords, they might not use the exact same phrases, but the system understands that the concepts building up that paragraph are maybe similar in other areas. And so we can say, if this paragraph is relevant to you, then look at these 5 other emails and chats. And you don't have to do it just by a paragraph. You can do that by word. You can do that by the whole conversation, the whole communication. And so we give you a set of technologies where you don't have to go and create a bunch of search terms. You don't have to go and do a bunch of manual reviews. We say, if this is interesting to you, if this is risky and you want to know more, well, here's 5 or 10 or 15 communications to look at next. So you can really quickly make a determination of whether something bad is going on or not. We also give you technology to quickly locate the content that matters. We've all seen Bloomberg chat rooms that can be 50 pages long, have hundreds of participants in them. And if an alert was generated, you don't have to scroll through that whole conversation. We have technology that quickly pinpoint the portion of the conversation that is relevant to you, that triggered the alert. We highlight that so it's clearly visible what's relevant. And there's a button where you can jump to that highlight. So you can skip the first 20 pages of that Bloomberg chat conversation or that email and focus only on what's relevant to you.
Thanks, Jordan. So just again, to recap, when it comes to increasing reviewer understanding, it comes down to a couple different pieces. It's around utilizing visualizations to tell the complete story. It's around finding similar related content that can help you paint a full picture. And it's about directing users, reviewers to specific aspects of a communication that are the most risky. And when you use these tools on top of the other two capabilities around removing irrelevant content, pinpointing the riskiest communications, and then increasing reviewer understanding, you're able to look at a whole suite of communications and identify the one that is the most risky. And that is a complete surveillance strategy. Again, removing irrelevant content to start, pinpointing risk and misconduct, and increasing reviewer understanding. And I know you're probably thinking, man, like this seems kind of complex, Peter. You've talked about 3 different categories, 15 different AI capabilities. I have to understand them all the ins and outs. I have to implement them. Well, luckily, you don't. With Relativity Trace, this entire AI strategy is built and automated directly within our standard trace workflow. It's running all the time on content as it is ingested into the system. So this allows for your compliance teams to spend less time thinking about the strategy, thinking about the software, thinking about how to implement it, thinking about the ins and outs, and more time trying to train your organization on what is compliant and what is not compliant, or trying to identify what is true bad behavior and who are the bad apples. So as you're thinking more about your communication strategy, think about Relativity Trace. Think about utilizing AI in your workflows to become the most efficient compliance team in identifying risk and reducing overall false positive alerting. Thanks so much for listening to us. Feel free to reach out if you'd like to learn more about Relativity Trace. Oh yeah, don't forget to fill out our survey. Let us know how we did. Let us know what else you'd like to learn about. Thank you so much and have a great rest of your day.